Good evening and welcome to October's live stream. Tonight we're going to focus specifically on program timescales and what we've got left to do to get you into your HX50. Before the final push on any major development program, it's often good practice to take a little look back and see just how far you've come in a very short period of time. Starting literally from a blank sheet of paper, we listened to what the market wanted and sketched out the concept for a next generation 5-seat helicopter. Soon that sketch became a wind tunnel model. The wind tunnel model became an engineering design. The engineering design became an aircraft, and the aircraft is becoming an icon for what the future of GA looks like. To deliver the performance that HX50 demands and the price correction that the GA market so desperately needed, we've had to develop the first all-new light helicopter gas turbine engine developed since the 1980s. Our advanced digital cockpit brings an all-new ecosystem to VFR helicopter flying, fusing the very best characteristics of traditional analog gauges with all of the enhancements of modern digital displays. Every aircraft has stability augmentation and advanced autopilot features as standard, and our active safety management system, which manages the status and health of the aircraft and also the performance of the pilot, is delivered through the Hill app. Clearly, to do these things, we've had to build an incredible team. We've combed the global aerospace industry looking for the best and brightest minds and pulled together a multinational, world-class team of specialists and engineers. To put this in perspective, if you were to take all the people in the world that really know about designing helicopters and developing gas turbine engines, you would be able to fit them all in a single cinema theatre. Okay, so the problem you've got is to get these people. They've all already got great jobs, they've already got established lives, and you've got to develop and evolve your own business to a point where you can attract these people to a better proposition with yourself. Now, however improbable that might sound, we've done it. We've built that team. It's always been a crucial part of our strategy to be a vertically integrated manufacturer. It's essential as an aircraft company that you make the components that you design and you don't just become a technology company. The scale and the extent of vertical integration that's been necessary to achieve our objectives has grown significantly during the program, and as a result of that, so has the facilities that have been necessary to do that work. We started development from a modest design office, very quickly grew to a first development center that handled precision machining and metal components, and then grew DC2 and DC3 to handle composites, patterns and molds. And then far earlier than intended, we've had to move here to Production Center 1, a 76,000 square foot, fully functioning production facility capable of delivering every component within the aircraft and engine under one roof. Now that is an incredibly complicated and demanding project in its own right. And as big and as difficult as that sounds, we've done it. Let's talk about development timescales. The challenge with any development program is the fact that it's not possible to know upfront every last detail of everything that you're going to have to do in the program, nor is it possible to predict every development challenge that you're going to encounter while you develop the program. You can certainly outline all of the key procedural steps that you're going to take to do the work, and you can make rational, reasonable, experience-based judgments on what a reasonable contingency is to cope with the things that might likely go wrong or might likely need some more attention as you go through that process. The reality is, however, that in every real development program, there will be things that you just didn't anticipate, things that you couldn't have expected, or things that are just a consequence of things that you've done along the way. And for that reason, it's a normal part of any development process to essentially have to periodically review the status of the program, look at where you are against where you need to be, and then to periodically update the timescales. And that's where we are now. There are two primary factors that have dominated the consumption of the available slack in our development timescales. Firstly, the extent of in-house manufacturing that we've had to go to control cost, quality and timescales has increased constantly throughout the development program. This has consumed far more development time and far more resources than we'd budgeted for in the original project plan. Things like developing gears and bearings and precision superalloy fabrications, castings, both in commodity materials and also superalloys, and then the development of in-house patterns and composite molds. All of these things are areas where we've increased the scope of the project, and this has unfortunately had an impact on the time it takes to complete everything that we need to get our beautiful helicopter into the air. Delivering all of that additional vertical integration has required vast amounts more space. And so we've essentially had to bring forwards the development of PC-1, an activity that wasn't planned until after first flight, in order to be able to complete the development and produce all of these components. The second effect to this is the fact that because we were bringing together all three development centres into Production Centre 1, we've essentially had to take our production capability offline to be able to take on a new building, build all of the huge infrastructure that's necessary to do all of these things under one roof before we can recommission it and get going again with producing the components, the test rigs, the test equipment, and ultimately aircraft and engines. To put that in perspective for you, in just one instance of the many we've had to deal with, we took our precision machine shop offline in April to prepare for the move of all of the temperature management equipment and then ultimately moving the machines. It's now the 16th of October, and this is the first opportunity we've had to finish the alignment of the CNC machines for the ultra precision components that we have to make here. While we've had to do it a little earlier than planned, what we've achieved here at PC-1 is nothing short of spectacular. We've installed all the engineering services necessary for production throughout the building. Lots of power. We've built the development suite. We've built conference and meeting rooms, customer reception facilities, constructed all of the specialist machinery foundations, installed all of our existing production equipment, installed a range of specialist lifting equipment, installed a dust-tight pattern and trim facility, installed a state-of-art pattern machining facility, developed a state-of-art metrology lab right here in the machine shop, installed a precision laser welding facility, installed a large-scale composite curing facility, a full aircraft paint facility, and installed a digital production control facility. We're now well underway with the construction of our glazing production facility. The structure for the mechanical assembly shop is now built and awaiting the internal furnishings, as is the trim shop just at the end of this corridor. We've now also completed the structure for the avionics assembly and test cell, the electrical assembly and test cell, and right at the end of this area, we've also built the wiring loom assembly and test facility. We've built and installed a secure parts storage area. The final piece in the puzzle is then the composites clean room that will allow us to build airworthy composites for the flying prototypes and beyond. The balance of space on the shop floor down there will then be used for the larger assembly tasks and also for the range of test equipment and rigs we'll need to qualify each of the components on the ground prior to flight. With this amazing new facility finally coming together, this will propel us through the remainder of development and then into production seamlessly. The fact remains, however, that in the original project plan, we really never contemplated having to spend this much time and effort building this facility at this stage in the program. It was always intended to be after first flight while we were going through the approvals process. So with the balance of PC-1 construction and commissioning complete by the end of this year and the full facility being fully operational, we can look forward to an amazing 12 months ahead of us, getting back to the business of producing prototype components, building test rigs and equipment, commissioning them, and then testing subsystems, doing ground testing, and ultimately flight testing. With the factory build now almost behind us, we have an amazingly exciting period to look forwards to. The starter generator is here and built, The test rig is on its way to us. It's finally cleared customs in Poland and is due to arrive any day now. At that point, we can finally do the starter generator testing, the motor generator control unit testing, and all of the associated control algorithm testing. In addition to that, we've completed the design of the speed reduction gearbox test rig. Much of the bought out equipment for that is here on the shop floor, and we're currently building the rig itself. The first of the intentionally airworthy speed reduction gearboxes for the engines are also being built at the moment, and we expect to be able to start testing those very early in the new year. That's the first 2 modules of this 4-module engine. By the end of Q4 2024, we'll have carried out the starter generator system test along with all of the associated power electronics. We'll have also tested the full avionics system along with the finalised HX50 digital cockpit user interface. In Q1 2025, we'll carry out the drivetrain test for the GT50 engine, the cabin crew seat crash test, and also the electrical system test. In Q2 2025, we'll carry out the gas generator module test, the power turbine module test, and then the first full GT50 run. On the aircraft programme, we'll carry out the undercarriage testing on both skids and wheels, and also the flight control testing. In Q3 2025, we'll carry out the first full engine test along with the certification endurance test. On the aircraft programme, we'll carry out the airframe testing, the fuel system testing, and the rotor system testing. In Q4 2025, we'll carry out aircraft drivetrain testing, ground runs, and then first flight. So with the information we now have at hand, we can update the key program dates as follows. GT50 will run for the first time on Friday, the 28th of June 2025. The first flight of HX50 is scheduled for Friday, the 20th of December 2025, and HX50 production will start on Monday, the 7th of December 2026. For most people, the single biggest barrier to entry into service for HX50 has always been its dependence on the GT50 engine. Those barriers will be profoundly eliminated when GT50 passes its certification endurance test for the first time. To celebrate that event, we'll be holding the 4th Hill Global Meetup and Discover event for Hill clients here at PC1 on the 11th of September 2025. At that event, you'll be able to see GT50 running in public for the first time. You'll be able to see all of the primary systems for HX50 on the test bench, and you'll be able to celebrate with us as we make the final push to first flight on December the 20th. The little dream of building a better helicopter has turned into a massive reality. We've crafted the helicopter that we all want, and to do so we've had to solve a plethora of complicated technical and commercial problems. We've had to vertically integrate an entire aviation supply chain to be able to simultaneously deliver on the cost, the quality, and the timescales necessary to bring HX50 into service. And now we've had to develop an enormous production facility capable of delivering every single part required for both the aircraft and the engine, all under one roof. This process has taken a little bit longer than we wanted it to, but it's an extremely complicated process that has to be done perfectly. The team are doing an utterly amazing job, and we have an amazing 12 months to look forward to as we bring each part of the aircraft and engine to life for the first time, culminating in that first full engine run on the 28th of June and that first flight on December the 20th, 2025. Thank you for the trust that you've placed in us to deliver this aircraft. Thank you for your support during the development program to date. And now it's time for some questions.